Hello and welcome to another video. This time we're going to look at how we read information from a directory. In a previous video we opened a file, read from it and wrote out a new file. However, we needed to know exactly what that file was called and where it was stored. In order to read what's inside a directory, we're going to be using the FAT file system API. We'll also need a recent version of MOS 2.2 or above. In our file today we're going to be doing two things. We're going to find out what the current working directory is, and we're then going to step through each file in that directory and get some information. The directory commands have only just been added to the MOS command API. These are documented in the Agon console 8 documents. There's a command for opening a directory, a command for closing the directory, and of course a command for reading information from that directory. In our sample code today, everything is included in the one file, so you won't need to include anything else. We have the usual start information here, and then let's get on to what we're actually going to do in this program. Well, the first thing we're going to do is load HL with directory path. This is a location where we're actually going to store the information of the directory. And BC is going to be loaded with 255. This is simply the maximum length we're going to allow, and that should be plenty. And the MOS call 9e is the new API to get us the current working directory. And this will be stored at the location of HL. If we look further down the program, we can see it here. This is where we're going to store that data. We're then going to load HL with a simple text heading and call our print string routine to print that onto the screen. We'll then reload HL with the actual directory path, set BC to 0, A to 0, and do an RST18 command, which will simply send out that text to the screen up to the first 0 delimiter. And to tidy things up, we're then going to print a carriage return after that. So at this point we've simply printed the current working directory to the screen. So our next job is to find out what's inside that directory. We're going to load HL with what's referred to as a directory structure. This is simply a place in memory where the information is going to be stored. We're going to load DE with the actual path directory, which we've already defined above, and then MOS call 91 will open that directory. So we're then going to go through a loop. We're going to read through that directory structure and it will list every file that's in that directory. We can then decide what to do with any of those files as we wish. We load HL with the structure, and we load DE with a file info structure. If we look further down, this is where those two structures are actually defined. And as you can see, there's simply a space of memory that keeps various attributes of those files or directories. So when we load the file directory structure and the DE with the file info structure and call MOS call 93, that will grab the first file within that directory. And next what we do is we check whether we've got to the end of that loop, and we can do that by finding out if the file name is empty, because we'll be given a file name for every item within that loop. If it's empty, then we've got to the end of our list. If it's not, then we're going to load HL with the file name and then print it to the screen. Similarly, to neaten things up, we'll print a carriage return afterwards and then jump back to the beginning of the loop. So all we're doing is stepping through one file after another within that directory until we've got to the end. Once we've got to the end, we're going to load HL with the directory structure address, and MOS call 92 will close the session. If we take a look at our Agon now, my current working directory is test. If I list what's in that directory, we can see that it tells us what our directory name is. We can see I've got a folder called More Files and a whole bunch of individual files. I've already loaded our application, so if we run it, you can see that it's done what we asked. It's printed out our current directory, test, and then it's listed every file in that directory. Notice that we haven't defined any difference between a folder and a file. If we look at the file info structure, you'll see that in addition to the F name that we've already used, there's an F attribute. And this contains a byte, and that byte has a various bit set depending on what type of file is in that folder. One of the bits dictates that it's a file, another will dictate that it's a folder. There's also a bit to determine whether in fact the file is hidden or not. So you can find out more information about each individual item you wish, as well as things like the date and the size of the file. Hopefully you'll find this useful if you want to trawl through a set of files within a given directory, maybe for importing pictures or sounds into your project.